This is ETT 10123 Software Defined Radio Board and is supplied with a complete zero install solution. One-step boot and run USB thumb drive has a pre-installed Linux with full GNU radio. A simple and practical introduction to software-defined radio with experiment implemented utilizing the popular open source GNU radio software.
The new ETT 101 software-defined radio capability is unique plug-and-play solution with GNU radio pre-installed. No downloading or Linux OS installation is required. It maintains a modular block diagram experimental approach, so the ETT 101 SDR module is used alongside other blocks on ETT 101 to implement the modulation and demodulation schemes.
It's probably these days the majority of the transmitted message signal are digital and originate from the computerized system. So it makes sense to use the PC generated data for the message in practical communication work, and this is the basis of this experiment.
With this SDR board, I am going to perform an experiment generating a baseband modulated message in SDR for passband modulation in hardware and then demodulation in SDR. In this case, the externally generated data source are replaced with internally generated baseband modulated digital streams of simulated data for the message in the hardware implemented QAM transmission system via IQ to passband.
Ensure that SDR utility expansion board is inserted correctly into the ETT 101. The ETT 101 is powered up and the SDR module is connected to the PC via USB.
Ensure the Picoscope is connected to the PC via USB and launch the Picoscope user interface app. Patch the arrangement in Figure 2 to implement the hardware elements of Figure 1. Open the Linux ETT 101 file folder and open the GRC file. Execute the GRC program. You should see a window similar to Figure 4 that displays the program's three graphical sync blocks of binary transmitter-receiver waveforms along with the Constellation diagram in GRC as well as in Picoscope.
And that's what wrap up our deep dive into baseband and passband modulation using SDR board. Today we explored DQPSK and GMSK in baseband and implemented QAM in hardware and visualized the Constellation diagram, tying it all together with seamless blend of the hardware and software for a complete communication system. I hope this has given you a clear picture of how the modulation techniques comes to life in real-world setups. If you have enjoyed this video or learned something new, give it a thumbs up and feel free to share your thoughts and questions or even the ideas for future experiments in the comments below. And of course, don't forget to subscribe and don't miss the next journey into the world of wireless communication. Until then, keep experimenting, stay curious, and I'll see you in the next video.